give just a few seconds here to let people join. I see numbers climbing right now, so give just a moment here for people to join. So thanks for joining us. If you're just coming in, we've got a bunch of additions coming in right now. Today's webinar is Decloaking Ad Fraud, and we'll go through a few of the housekeeping items first. My name's Kimberly Manning. I'm the VP of Marketing here at Kochava. We're pleased to have you with us today. And I'm having trouble advancing to the next slide for some reason. I wonder, Jeff, if you can help me with that. There we go. Thank you so much. So just want to let you all know, as you're joining here for the ad fraud webinar that we're doing today, that I want to give you a few pointers about the platform that we're on, Goldcast. If you haven't used it before, there's some features over on the right side. There's a chat. We encourage you to jump in and connect there and let us know where you are joining from. We love to have interaction on our webinars, so please feel free to jump in and share your thoughts there. There's also a docs tab where we have some related information to this webinar, so some additional helpful items that you might want to download. And then on the far right is the Q&A tab. As you have questions, please feel free to add them there. We will try to get to every question today. Okay, I am still having trouble advancing slides for some reason, but I'm going to bring our guests on for today. So we have joining us today, we have Grant Simmons, who is our VP of Kochava Foundry, and Tyler Levasseur, who is the manager of Foundry Data Analytics. Kochava Foundry is our client services arm, so they are particularly good at digging into difficult problems. And on this particular topic of fraud, I think you would be hard pressed to find anyone with more experience and expertise at identifying and mitigating fraud for advertisers. So really thrilled to have them here. And I just want to point out, as we're going through the webinar today, if at some point you're just thinking, holy cow, I need to talk to these guys, you can request a fraud consultation with the button in the upper right. So I'll hand it over to you, Grant, to introduce yourself.
I love it. Hey, thanks everybody for joining. Grant Simmons, VP of Foundry. And this is a topic that's near and dear to my heart. And so once we get into it today, what we're going to do is walk through some sort of historical cases. Dovetail that to where we are now in terms of detection and mitigation, and then we'll talk about what we think's coming and maybe get some of your input as well. But with that, let me have Tyler introduce himself. And by the way, before Tyler starts talking, much of what we're going to go through today is because of this guy, and he is an unsung hero when it comes to ad fraud detection. And so I'm really happy to have him with us.
Awesome, appreciate the kind introduction.
I like that for a setup.
Yeah. Yeah, hi, I'm Tyler, manager of data analytics at Foundry. I'm super excited to be here. This is going to be a fun topic. I love talking about this, so feel free to reach out.
Cool. With that, let's launch our first poll, and we'll take a bit of a temperature in terms of where folks are with their approaches to fraud, how they think of fraud. Do you think you're being defrauded, et cetera, et cetera? So the poll is here real quick. Do I share this? Do you share this? Oh, we can go. Yeah. Okay, so I'm going to submit. There we go. And while folks are taking this, let's talk about what we're going to cover today. There are lots of different types of fraud out there. And when we talk about digital ad fraud specifically, it is the second largest criminal enterprise, organized criminal enterprise on the planet. And just so happens that mobile marketers and the industry that's in first place both call their customers users, right? And so there's a little bit of overlap there. But the reasons is because there's not a lot of risk, and the rewards are pretty substantial. So as these come in right now, it looks like the the median's going to be around that fairly familiar. And if you've been around mobile marketing, you've certainly heard this fraud drum being beat quite a bit. Well, with that, let's get into it. I'm going to share our next slide here real quick. So specifically to set expectations for today, we're going to take a bit of a walk through history. But what we're talking about is largely performance fraud. And when we think about the performance spend, you can see that over on the right-hand side. When we think about fraud just writ large, it was 95 billion in 2023, and it's estimated to be 172 billion by 2020, by 2028. So what does that mean? It means that theoretically about 40% of your ad budget is going to go to fraud if things don't change. But we're not going to get into lots of different fraud today. We're not going to get into the types of fraud that are being levied to specifically defraud publishers. We're talking about the performance fraud, largely within a mobile universe. And so with that, let's sort of jump into the past here real quick. We're going to go through two sort of findings and investigations. And the first one was with Cheetah Mobile. A lot of you probably heard of Cheetah Mobile. It was a publicly traded company, still is, on the New York Stock Exchange. And they had a suite of utility apps like cleaner apps and folder apps and even a flashlight app that did ostensibly the thing you downloaded it for. But the other thing it did was it listened to activity that was taking place on device and figured out when to, in a fairly sophisticated manner, look up, well, what app's being downloaded? What's the value of that app being downloaded in terms of a CPI? And should I inject a click for it? And so we figured this out. And by we, I mean Tyler. And I'm going to turn it over to him real quick. And we'll talk about how we found it and the specific row level detail. But note that, this company's never really recovered. We go look up their stock price now. But this was an absolute sort of kneecapping. You can go back and Google Kochava BuzzFeed. And what I'd say is, in terms of the tactics that are laid out, much of it's still pretty hard to do, but much of it is still taking place. But let me shut up. And Tyler, I'm going to turn it over to you for a sec.
Sure. Yeah. So what we're looking at here was a test that we performed to see this happening in real time, to sort of capture all the little details of what's going on in the device. And it's a lot to look at, but we can get through it together. What we did is we proxied this device to look at all of the HTTP requests coming in and, the responses coming into the device and what it was, pinging to look for. What you're looking at the top row is, after we had installed this particular Cheetah Mobile app, we, let it do its thing, shut down the app. We went and installed from the Google Play Store some other app. In this case, it was Yahoo Mail. And so the first two red boxes there represent that process, going to the Play Store, searching the app, and starting to pull down that app from the Play Store. The next several red boxes that you see is a flurry of what I'll call advertising activity. Now keep in mind, there was no ad shown, right? This was a completely organic install in the sense that, there was no ad actually being displayed, but nonetheless, a bunch of clicks were fired off. And you can see that. And the final one that's sort of interesting here is line 103, a click to apps flyer. And so what that means is that, in this case, the MMP for Yahoo, being apps flyer, when this app were ever to launch, apps flyer would go and try to attribute the most recent click, just last click attribution, and they would actually find a click despite no ad ever being served, right? That's what we mean by click injection. And in this case, something extra also happened, which is that in the final couple boxes there, that's internet traffic from the Yahoo Mail app going to the Yahoo servers. So what happened is the app was launched in the background. I did not, as the one performing this test, did not open the Yahoo app, but there was some mechanism by which it was able to be opened anyways. The salient point there is that the fraudster not only injected the click, but also closed the loop, right, to force the attribution function so they could gain the last click attribution. So when we look at the clicks to Apps Flyer in this case, or the click that was registered to Apps Flyer, it looks kind of like a normal click. I mean, it's exactly, there's nothing really sort of wrong with the formation of this to give a sign that this was fake, right? This was all normal behavior, and you can see the response there at the bottom left. It's a 302 redirect, that's standard, back to the Play Store. So everything worked as intended for this fraudster, and they were able to claim that this install was the result of a ad being served and a human click. And so this is a classic example of click injection. Now I want to bring up one more point before I turn it back over to Grant, which is that how would you detect this in, your data set, right? You're not going to be proxying all your devices all the time, right? You're not going to be able to see all this detail happening. But one thing that I should bring up if I go back really quick, all of this happened relatively quickly. I mean, I don't know exactly off the top of my head, but it all happened, let's say less than a minute. And in terms from when the click happened to when the the app was launched for the first time, only a handful of seconds. And so one thing you might look for in the data to suggest that this is happening is a very short, what we call time to install, time from click to first launch. That'll become important a little bit later, but just kind of think about that in the back of your mind of what types of signals you might be able to actually detect in the data if you were to look for it. Great. So I'll turn it back over to you.
And you bring up a really interesting point, which is there's a real install that took place and there was gamification, basically trick attribution, right?
Mm-hmm. Yeah.
And we could only see it at scale after the fact. Meaning, how would you see this in your own data? You're not going to proxy every single device that's going to install. But how this is going to manifest is, statistically speaking, there is going to be a universe of outliers, which is going to say, dig into this. And that's what led us to actually start proxying devices, because we saw anomalies at scale, which couldn't be described. I'm getting some feedback that folks aren't hearing me on the call. Can you guys hear me?
I can hear you.
Okay. Yeah, I appreciate
that. I can hear you.
Okay. Well, okay. I'm gonna keep pretending like people can hear me, and I'll smile a lot.
Thank you to those who are answering in the chat there. Sounds like it might be a specific problem. Nate Gasser. Hi, Nate Gasser. Okay. I think we're having an audio problem. It looks like it might be isolated.
Yeah, interesting. Well, I'm going to keep going here. Hey, the other thing I didn't mention, I usually mention this at the top, is please ask questions. We might not get to every single question in the webinar, but we will answer every single question in written form afterward. And so we'll post that. In terms of the questions we answered here and all the questions we collect along the way, we'll do our best to answer all of them. And that'll probably be posted about next week if we don't get to it today. So that we talked about using kind of detection at scale to tell us where to go with something. And the next case I want to talk about is Uber. And so for those who aren't familiar with it, this was and I think still is the largest ad fraud lawsuit in history. There was $142 million in ad spend. And it implicated Fetch, Funware, AdAction, UAPI, Taptica, BidMotion. And we won all the lawsuits. And I want to talk about how we did that really quick. A lot of the stuff I'm going to share here over the next couple slides might seem sort of inflammatory, but what I would say is you can look up that case number in the Superior Court of State of California. Everything I'm going to share is publicly available and is part of the actual legal record. So Uber approached us. They were not a Kochava client. They had a different MMP. They were using Tune at the time. And that doesn't matter, and it still doesn't matter for when we talk about auditing fraud later on. But ultimately, they piped to us 68 billion rows of data, which covered about a 1.5-year time frame. And so with that, we ran all of that through our algorithms and created records at a per network level of what we thought was fraudulent. You see one of those on your left-hand side. That was the one that was generated specifically for Funware. And so ultimately, if you round, we thought 100% of the installs that were attributed to Funware came from fraudulent means. And so we would break that out into, like what we just talked about with Cheetah Mobile, that is all ad fraud on the ad signal side. Somebody's lying about an impression, somebody's lying about a click, but there's a real conversion. There's also another type of fraud, which is somebody's lying about the conversion. And oftentimes a fraudster will lie about both. And we saw some of that in this case. But in terms of the activity here, it was coming back to Uber with a record of what we thought was fraudulent and then working with their trial attorneys to create lists of things to go discover. Go subpoena this database. Let's go talk to the CTO. Let's go talk to the salespeople. And ultimately, I read 35,000 pages of deposition, and we would foot that back to the data. And so an example of that would be there was falsified transparency, and there were attempts to falsify that transparency, which became pretty clunky and pretty obvious. And so what we see here is a discovered email from the agency saying, hey, Uber demands transparency. If there's a site ID or a sub-placement ID of an app where an ad's being served or a website it's being served on, let us know what it is. And so this is the types of things they would get back. They would get back MP3 player number 83. I don't know what MP3 player that was, but there's also an MP3 player 20 and an MP3 player 29. And there's Music Play and there's Music Play Pro and all these things that sort of sound like apps, but once you sort of dig in and you look at all of them, you can very quickly realize that many of them aren't apps. And so when the network themselves started to be subpoenaed and discovered, things like this would come out. So, hey guys, and this is internal conversations within the Phunware sales folks. I think offers us the ability to change the name displaying on our tracking links, meaning what's going to get reported back to the advertiser. Hey, I had a thought. If everybody else is doing it, can we just look at mask our name in the tracking URL, right? And so we would see a lot of hard coding in the site ID fields. Somebody was saying, regardless of where the traffic was actually run, this is where I want you to report it as having come from. Let's go a little deeper here. Another salesperson say, hey guys, Uber requires real-time site names. So you know what? We're just going to spoof them with the list of names you gave me. So in an email prior was a list of bogus app names and just saying, hey, we're going to take where the traffic's really playing and we're going to report it as this stuff. And for the sake of legal clarity, the attorney saying, hey, by the way, spoof means fabricate, right? They're lying about it. And then finally, this one's such a gem. Another sales guy. Hey guys, it's that time of the month. No, not that time. It's time to spin some more BS to Uber to keep the lights on. That doesn't read really well. So the subpoenas and the discovery started flying. One of the things that we discovered, and we got this from the CTO, was a bunch of domains had gone down and the sales folks had piped up saying, hey, dailyprizegiveaway.mobi, that's down. And the CTO would say, like, what does this thing do? And they're like, don't worry about it. Just make sure it goes back up. Well, here's what that was doing is there was ads being placed, which were Uber's, which were being placed on Asian porn sites. And every time that the ad was served in a pop under, it reported a click to the MMP. So kind of a double whammy there. First off, it's not a click, it was an impression, and it was a pop under impression that nobody saw. So that's the first thing. The second thing is that laid a claim to and was scrubbed through to make it look like app traffic, such that anybody who sort of did two things, surfed this Asian porn site and downloaded Uber, whenever those two unrelated things happened, Phunware got paid $9. So specifically, how did they do it? Phunware set up links and has offers. This is where the money laundering and the data laundering took place. Within here was the ability to call your publisher anything you want, and you could change the name as much as you want. And the reason there was a summary judgment against Phunware, which we used to settle the rest of the cases, meaning we won, was they deleted this database. And so it had the record of who was getting paid, how much, for what, and it was the thing that was ultimately deleted. But here's how it worked. We discovered a couple of these PHP jump pages. And so what we see here at the top of this PHP jump page, this was dailyprizegiveaway.mobi, meaning anybody who was routed through that Asian porn site who went through this 302 redirect would never actually see dailyprizegiveaway.mobi. But what it would do is it'd say, hey, take one of these apps up here that we can recognize most of these names. Randomly choose one of them and plug it into this tracking link, which is a has offers tracking link. Meaning regardless of where the traffic's coming from, call it Rolling Sky or Piano Tiles or Heads Up or Steppy Pants, and then report it to the MMP. And so ultimately, when we got our hands on all of these different scripts and we would look at the traffic coming from these scripts, this is what we saw, is we would saw non-human traffic patterns, because it's just a random sprinkler of choose this one, choose this one, choose this one, choose this one. None of it was actually legitimate traffic. And so it was this record that actually sort of was the nail in the coffin. But a couple things here. First off, we learned so much during this. This became a fraud algorithm of ours called metric smoothing, meaning you would expect this to, in statistical terms, be monotonically decreasing with no plateauing if it was actually human. And we don't see that in this case. And so this is an example of something that is now informs our real-time algorithms. And so that's a bit of a walk through the past. With that, let's talk about sort of where we are now. With that, let's launch that second survey question if we can. So if everybody goes to the survey tab, what % of your mobile ad budget do you estimate was lost to ad fraud over the past year? What do you think? Very curious where folks think on this one. I might have spoiled the jury with that 40% number earlier, but yeah, okay. Yeah, most folks are coming in on that moderate. And so regardless of where the percentages actually lie, I think most folks recognize that moderate ad fraud tends to be a thing. So let's talk about where we are with it now. We think of fraud in terms of detection, mitigation, and customization. And so I had mentioned earlier when we were talking about the Uber case that there's fraud on the ad signal side, there's fraud on the conversion signal side. And what you see here is generally how we think of it. This is the list of our algorithms. And historically, these haven't all been publicly facing. I'll talk about that in a second. But what we see is over on the, let's say, flooding ad signal, we see lots of naive attempts at flooding ad signal. We used to see lots of ad stacking, don't see it so much anymore. Still see plenty of click flooding, still see plenty of geo outliers. Oftentimes we see platform differences. That started to pop up in CTV a little bit. We'll talk about that one in a bit. And then you've got a more intelligent, meaning something is listening to something else to figuring out what to call or how to report ad signal. And that's that intelligent ad signal. And then you get into falsifying transparency. And so now we're trying to mask either the ad event or the conversion event. And then finally we get into manufactured conversion, which is we know the device itself was fake. We know that conversion wasn't real, or we know that device was real and the conversion was non-human. And so there's a handful of algorithms we look at with that as well. And so if you've been a Kochava customer, you've probably seen our fraud console before. We've been working on our UI here for the past few years and are rolling out the new UI now. And one of the added benefits are there's going to be a bunch of new fraud views. And so we have a lot of the old hits like click flooding and MTTI and TTI violations and ad stacking and anonymized installs, things like that. But now we're pulling in a lot of the conversion fraud as well. We'll take a look at jailbroken. That tends to be a big deal. If you see that 100% of your attributed universe to a specific publisher is all jailbroken devices, that is a big red flag, and we still see it. Another couple things is if you're an SDK client, we're going to talk about install validation later. That is a good, awesome way to just set a flag to kind of mitigate the bad of the bad. And there's a couple other things you can do as well. And so, hey, good news, we've got a bunch of new fraud views that'll be publicly facing. But don't worry, we still play the classic hits. And with that, I'm going to hand it back to Tyler to talk about some things that we've seen recently.
Yeah, awesome. Thanks. So this is an example of what Grant was talking about earlier with falsified transparency. What I'm going to walk through here is, again, sort of what we see in the data because we don't always get to read our fraudsters' emails and see what's going on, right? But what can we see when we look into the data? So this is an example. What you're looking at here is traffic from a classical just DSP network, not a SAN, and you're looking at clicks by day. And up in the top right, you have the site ID. So this is where the clicks are supposedly coming from. And when I do this in person, I typically take some time and ask the people, what's wrong with this picture? But since this is sort of virtual, I'll tell you the number one answer I tend to get is that they're suspicious about the gaps. There's not clicks reported every day. That's fine. I don't see anything particularly unusual about that. That happens sometimes. The server adds one day, not another. Things like that happen. What I look at here is the site ID that they're claiming to be putting ads on, and the MMP is receiving clicks for, in this case, us. It's from com.facebook.orca, which is the Facebook Messenger app. Right? This is not a place where a DSP can place ads, right? Facebook is a walled garden. They have their own ad serving tech. You're never going to get a DSP placing ads there, right? So automatically we know, okay, this is not a legitimate, transparent site ID. So there's that. Let's take a look at another example. Oh, I can't use that button. There we go. This one. And I ask, okay, people, what do you see here? And people tend to cue in on it. This looks exactly the same, changed colors, and it's from a different app, com.applon.optimizer. I'm sure you're familiar. That's Booster Kit. So if we are to kind of believe what these site IDs and that they're transparent, when we overlay them, we're to believe that Booster Kit has the same reach as Facebook Messenger, which doesn't really track, right? These are clearly, this is a case of the site IDs just being randomized. They have a huge bulk of traffic, and they're spreading it out across different site IDs. And then there's not just two. We can add in a third, a fourth, a fifth, and we all see exactly the same pattern, right? This is all just overlapping. And so this is what creates that metric smoothing that Grant was talking about a little bit earlier. So what happened? I took 5 site IDs, but what happens if we take sort of all of them and just plot them with a very faint gray line, and there's thousands of them? What emerges is this. You see that there are hundreds, in some cases thousands, of site IDs that move in exact unison with each other. I mean, there's some variation, obviously, but they're having exactly the same kind of pattern. And so it break out into 3 groups naturally like this, which is a big red flag that there is some falsified transparency happening here. And I would call this definitely inauthentic behavior. So that's this falsified transparency aspect. I'm going to switch over a little bit and go into what I call smart click flooding. And so what's going on in this case is another thing you can look for in data is sort of signals that that someone's trying to game the system. In this case, what we're looking at here on the top is unattributed traffic, or attributed installs that were what I call everybody else, as opposed to network A on the bottom, right? So I've changed the network name, it's just network A, somebody, and we're going to compare how these installs got attributed. So on the top, this is from a web app as opposed to mobile. We look at the OS of all of the unattributed installs, just sort of the background organic installs, or in this case, web visits. iOS had about 36% roughly of installs, Windows about a quarter, Android 18%, right? And it kind of trails off from there. If we look at network A at the bottom, what were their attributed installs looking like? Like very, very iOS heavy, 94%. So that's different. I did ask the advertiser, I said, is there any reason that you would expect this from this network. Are they, let's say, iOS centric or something? And they assured me that no, they're not. If we look on the right-hand side, if we look at what kind of IP address are we seeing? Is it cellular or not, right? Because cellular IP addresses are very popular in terms of they have a lot of traffic, right? If you're out and about, not in any one building, you're not at home, you're not at the gym, wherever you go, you're going to be on a cellular IP. So we see that around, in this case, 47% of the time we expect to see cellular IPs. If we go to network A, it's 95%. So what's going on here is that they've isolated a set of user agents, and specifically iOS user agents, because there's much fewer of them. And they've sort of combined the signals of user agent and IP address as what we need for fingerprint matches in such a way that by taking a very few user agents and a handful of cellular IP addresses, you're able to gain attribution much more easily, let's say, because there's a fewer set of possible combinations you can actually get that way. And you're able to game the system much more efficiently than you would be in just sort of standard click flooding, I suppose, where you're either trying to just randomly match on an IP, or excuse me, a device ID, which is much harder, or let's say you're on an Android user agent where there's hundreds and like several hundreds of possible user agents versus the handful that are with iOS. And so they're able to sort of be intelligent that way. That was sort of an interesting thing, and it's worth looking at occasionally from time to time with different networks to see what's going on there. We touched a little bit on earlier the idea of time to install with that Cheetah Mobile example at the beginning. One thing that we like to look at, or I like to look at, is TTI, and what does that distribution look like? So again, time from click to first launch of the app. How do those times tend to distribute themselves? And when we see good clean traffic, the graph looks something like this. So I'll just walk through what this is real quick. The gray sort of shape, that is the distribution of installs across how long it took from click to that first launch. And we see that it peaks sort of around 30 seconds, and maybe by the first few minutes, most of the people that have installed the app get through that entire process. And we see a nice little decay as it goes down from roughly 30 seconds all the way out through the end. We capped it at 5 minutes. Of course, that does continue. It's not only the 5 minutes, but we're just sort of zooming in on that little area. It's overlaid with a couple different lines. You see the blue line. That is the number of session begins on average for that cohort of installs. Number of sessions that the user had within 7 days of installing. And then there's a quality metric, and that basically is a take rate for a specific KPI of value to this particular client. So think of it as maybe like a purchase or something high value like that. And we see that generally it's fairly, right, it's fairly consistent. There's a little squirreliness as you get into smaller sample sizes towards the right, but it's fairly consistent. When we started looking for click injection, like I said before, one of the things we started noticing is that the TTI might sort of bunch up towards the left, meaning it only takes a very short time for this click to trigger that install open to close the loop on attribution. So they get through this process, evidently, in like a handful of seconds. So one thing we noticed is that instead of closing the loop very quickly, they tend, fraudsters have tended now to space it out a little bit because people started looking for those short timed installs, very short. So if you can try to erase that fingerprint of, this telltale sign by maybe spacing out your installs to click times towards the right a little bit, you might go undetected. But what we ended up seeing is something sort of like this. Which is obviously very scripted behavior as well, right? Like if we were to try to say, what does this tell us? This would mean that a cohort of people, for whatever reason, they click the ad, download the app, and they wait like 90 seconds, but they kind of split off into two little groups, and then sort of all launch at the same time. And then another cohort, wait 30 seconds longer and do the same thing. And then 30 seconds longer, do the same thing. It just doesn't make sense, right? This is very much a process of trying to control that time so that the fraudster doesn't trigger a ton of installs within, let's say, 10 seconds of click, because that could be a red flag. So if you space that out a little bit, it won't be flagged automatically for a ton of short installs or short TTIs. We also see during those spikes that are very suspicious, the quality, meaning the KPI take rate, spikes really high, and the number of installs, sessions launched by those installs dips very low, which means that it's also a sign of scripted behavior where these installs, they trigger one session, do a KPI event like a purchase or something valuable in the app, and are never seen again.
Mm-hmm.
So this is, again, scripted non-human behavior. A couple final things here, things to look for in the data. So far, what we've looked at is more statistical, right? Where we don't see any one particular install being necessarily fraudulent. We detect this at scale. There are some things that we can just look at by digging into the data a little bit. Here's an example of a bot traffic where the ADID, so the device ID, came through as a bunch of characters that we don't typically expect to see. Of course, we print it out. Turns out to be some Chinese text. And I don't speak Chinese, so I threw into Google. It says query exception, unable to open login. So clearly what's going on here is that there is a, let's say, I'll call it an install farm, where they're trying to grab ADIDs from a table somewhere and grab that and stick it in the payload. And of course, occasionally there are errors. They fail to grab it, and they just put that error message in, right? So it's a telltale sign of a script gone wrong, right? It failed and sent the payload anyways. And so this is, of course, something that is easily detectable at the row level. This particular install obviously is not real, so it's worth looking at. We see it a couple times. There's a similar error message. So in this case, the SQL Server was being used as the table, so a little more information there. In this particular case, the device was rooted, so jailbroken. We tend to see that a lot for install farms. It's just easier to work with a rooted device and have your scripts install apps sort of programmatically, which is another thing to look out for. So one of the things our SDK does check, it tries to find out if a device is jailbroken or rooted. So when we look at, a particular client's traffic in this case, they were running with a lot of different networks. We plotted what percentage of those installs from particular networks were jailbroken. And for the first three on the left, that was nearly 100%. So almost every single install that got attributed to these networks was rooted, which is a big sort of red flag, right? There's no way that I know of for a network to target specifically jailbroken devices. And that should theoretically be a very small universe anyways. That would not be a good tactic for the network to take, right? It doesn't help them. You would be really sort of targeted at that point to the point of being useless. We expect to see, a couple percent max across the population of rooted devices and sort of legitimate traffic. So a very small percentage, not 100%. So there are quite a few different networks that really sort of spiked off the charts in terms of percentage of rooted devices, and then sort of trailed off. So that was an interesting exercise. They were able to, make better decisions about who to run with in the future in that case. So that's what I have. Grant, we'll kick it back.
Yeah, it's interesting. We got a couple of questions that popped up during one, and Amelia asks one. that is very real world, and it sounds like something that you and I would have maybe been asked or still get asked today. And I'll just read it. How would you handle this? Dozens of mobile apps generating clicks from a bunch of cities from the US, but discrete cities like Santa Clara, Chicago, New York. But one app is generating 100% clicks from one city. The IP address indicates that it's VPN or anonymized. Apps have greater than 60% click-through rate. Where to go next? So, yeah, it's interesting. So I'll tell you where my head goes. Is first off, and we'll talk about this later, but you're probably sitting on the sufficient ingredients to do a bunch of ratio testing to understand what's likely going on. But where my head goes is the timing of these things, the OS, how that gets grouped, referral strings that the signal's carrying. Ultimately, what's the profile of customer it's attributing to, and are there nuanced differences there? But that's where my head goes. Given that question, where's your head go, Tyler?
Yeah, I would tend to think of what's the post-install behavior as well. Oftentimes with situations like that, if they are, let's say, completely manufactured installs, you may see, like a couple slides back, the fraudster had to guess at what the KPI conversion rate should be. And it was well above, they very much overestimated, let's say, the frequency with which people purchase, or sometimes you see it go the other way. There's no post-install event behavior whatsoever, right? So it's basically create an install and then never launch the app again. There's significant differences that could be assigned. Yeah.
Also, and I'll bring this up because Mayor brings up a good point as a question. Also, for long TTI, it's also good to understand what is the size of the app and where is the app being downloaded from, because not every geo is going to have the right sort of connection. We do, when available, look up the connection type, largely off of sort of some IP intelligence and indexing. We don't get it every time. That TTI stuff isn't quite as, what I call it, trustworthy as it used to be for the reasons you bring up. But when you still see cohorts or multi-modes show up, it is generally indicative of something having been manufactured. And the fraudsters have a hard time manufacturing everything that needs to get randomized as well. So, but you do bring up a really good point. I want to acknowledge that.
Yeah, and another thing to point out is that, well, I'm not making the claim here that this exact shape is what you should see. Of course, the size of the app, where you are, all of those things play a role. We do typically see this kind of shape, even if it is shifted to the right a little bit, because it may take longer. But what you don't expect to see is something like this, right? The size of the app being, say, larger, won't make everybody sort of perform at the exact same intervals. That's really sort of the salient point there. But yeah, that's a great point.
Yep. Love it. All right, let's move on. Hey guys, hey, keep asking questions. Again, if we don't get to it in the webinar, it looks like we got probably about 10 minutes left or so. We will answer the questions after the fact. So let's jump into the next one. And I had mentioned earlier that when we think of digital performance fraud, we think of it in terms of detection, mitigation, and customization. And when it comes to that mitigation and customization, that manifests largely within our traffic verification product. And so this is an example of how Traffic Verifier thinks, meaning all of that ad signal and raw conversion and all your clicks, impressions, events, conversions, all of that's your raw ad signal. And so the first thing that we'd run it through is SDK authentication. I'll talk about that in a second, but that is meant to, within our SDK, if you're an SDK client, strongly recommend you turn this on. Because when the SDK fires, we can listen to lots of signal, and we understand certain types of signal that we would expect. And if those don't agree, we know it's a fake device. I'll talk more about that in a second, but this is a huge call out to turn this on. The next one is the global fraud blocklist, meaning we have a catalog of known site IDs, IPs, devices, et cetera, that have demonstrated fraudulent activity sort of writ large across multiple accounts. And that creates a catalog that you can very easily flip on to keep your traffic protected. The next one gets into customization, and Tyler and I within Foundry, we spend a lot of our time doing fraud consultations to figure out, well, what should my bespoke rules be at a CTI, at a timing level, at a device level. Much of everything in all of our algorithms can be customized to be able to carve around specifically what you're trying to do. Recognizing that the mobile DSP world is, it's shark infested waters, we kind of want to build you a chainmail suit here, and we can build one custom for you, such that we can carve around geos, and we can carve around OS versions, and we can carve around specific DMAs. Everything that you see on your screen creates a weapon to be able to give you the confidence to swim in those waters. So just turning this on isn't the end all be all. The work still takes place. But first off, let me talk about install authentication. If you're an SDK client, turn this on. At sort of like writ large, if we were to glue everything together, at what rate does this fail? It's a little under 2%, meaning of all of the authentications that we assess at the device level to say, do we, from our SDK intelligence, understand this to be a real device? It fails at about a 1.8% rate. But if we look at kind of the network sub-publisher advertiser level, there are some rates that are as high as 40%. Meaning 40% of a network's referred traffic base we believe to have come from or are impacting fake devices. So this is a great way to get clean super fast. And then finally, once all the traffic verification rules are turned on, you got to create some reporting. Now, one of the nice things about Kochava is even if we fail the ad signal, we verified it, it ran through traffic verification and it failed, we'll still log it. And we'll log it with its failed reason. Did it fail because of a custom threshold? Did it fail because it hit the blocklist? Did it fail because it was out of the money with timing? There's lots of different reasons. And so for every failed ad signal, we can aggregate the reasons. And then also we can dig deeper. So what we're looking at here is an ongoing report that we generate for a client to say, here's the amount of traffic that is making it through verification on a partner level. Here's the amount that's not. When we look at the amounts that's not, we'll oftentimes get into reasons why it's not failing. And in this case, what we see is invalid purchases, meaning we see these site IDs that are referring conversions. Well, another check that we like to make is if we see a purchase event in the app, do we have a corresponding purchase receipt from the App Store? Because we should. And so this is a big red flag. And so that's why I say is oftentimes like traffic verification, turning on that mitigation is the first step. And now we got to dig in and actually start cleaning stuff up. So that's sort of where we've been, where we are now. Let's talk about where we're going. And so, hey, let's pop that last survey real quick. I really want to get folks' takes on what they think AI is going to do to ad fraud. Do you think it's going to make it easier to detect? Do you going to think it's going to make it harder to detect? And you have to pick one. If you think that it's even, pick no difference, and then be honest if you honestly don't know. Harder to detect. Yeah, that's sort of the nature, isn't it? Interesting. Yeah, it looks like most folks are sort of in agreement here that it's going to make it harder to detect.
That's interesting.
Yeah. Let's talk about it. So first off,
Sorry, I messed you up there.
Oh, no worries. This is something we're seeing recently, and it's probably reasonable that we will probably see more of this in the future. And so what we're looking at specifically here is fraud that is taking place on one of the big self-attributing networks. And the reason we can see it is no individual row level record will violate, but you can see it in aggregate after the fact. And so if you were to take things like, what was the total install time that this app universe took across all of these conversions, and then plot that with, let's say, volume on the device. And you'll see these perfectly little constrained universes that are obviously non-human, where all of the installs took place within a very narrow time frame and all had a very narrow setting of, let's say, volume setting on the device. And so we'll run that through a lot of other device parameters, and we keep seeing these monoliths pop up. So the reason I bring this one up is in a world where signals being redacted more and more, we don't pretend that we've cornered the market on fraud detection. Listen to everybody and talk to a lot of folks. There's some real experts on this call here today. But it's reasonable to assume that this stuff's going to get harder to detect and is going to get harder to detect at a row level. I think that's a reasonable assumption for the future. The other big change we've seen in mobile marketing is largely around CTV. If you'd told me, 5 years ago, I would spend as much time measuring eyeballs on the living room screen as I am on mobile phones, I'd have called you crazy. But that seems to sort of be the case. There's a lot of eyeballs and there's a lot of money moving to CTV. Well, the good news is fraud's already here. And if you want to see some really gnarly fraud, just go to go to Amazon and search cheap Android set-top box. You can buy one of these boxes for maybe under $25, and it does all the things that you bought it for. You can download Netflix onto it. You can download other apps onto it. But just proxy it and watch what it's doing. Watch all of the signal that leaves that device and all of the ads that are being reported that aren't being seen by a human. And so it's sort of the Wild West right now. CTV, I would argue right now, is very vulnerable because it's in its growing phase. There's a huge lack of standardization. And we've already seen lots of click spamming and lots of manufactured devices. So at the row level, a device that's, let's say, pretending to be two things. It's pretending to be an iOS device and it's pretending to be like a Samsung TV. And so until these pipes are hardened, I expect we're going to see increasing levels of fraud on CTV. The last one's AI, and I always want to talk about this one real quick. When I answered that question, I think there's probably no difference. This is the cat and mouse game of ad fraud. And I think what AI is going to do is it's going to make that cat and mouse game a hell of a lot faster, right? And, Tyler and I chat about fraud a lot, and he likens it to the Ardennes forest, such that you build a bunch of placements and then the enemy just goes around. And then you move all your placements and the enemy just goes all around. And that to some extent is still the game. Here's what I would like to see, and here's what I know is possible, and particularly, this becomes possible particularly for Kochava because we keep all of that row level data and we keep it around for as long as the advertiser wants to keep it around. So theoretically, we live in a world where you could point AI at petabytes of data and say, go detect those anomalies. But it's not just an AI problem at that point. It's a compute problem, it's a processing problem, it's a storage problem, meaning nobody's done this yet. But I'm actually a little bit bullish here because we're sitting on the necessary ingredients to be able to detect this stuff in mass, at scale, in aggregate. So I'm actually maybe even a little more hopeful for AI on the white hat side than the black hat side. Hey guys, we're coming up to the end, and so this is the time where I'm just going to give a shameless plug. And the reason I'm going to give the shameless plug is we have done hundreds of these. We're very, very good at this. And if you think you've been defrauded, you probably have been. And if you just want to find out more, go download this one sheeter. There's some real good tools in there. If for nothing else, there's some good IO language that you can add to keep yourself safe. But what do you get out of this? You get out of this an overall assessment of where you are. You get a list of recommendations to change at the partner level, all the way down to the tracker level. You get exception reporting for what is being verified and what's being mitigated, and why what's being mitigated is being mitigated. It also creates a very nice connective tissue back to your network partners because they're not caught unawares. Everybody is on the same sheet of music. So strongly recommend folks download this, check it out, and get in touch. How are we doing with time? I felt like we were running a little tight. Kimberly, how are we doing?
We still have about 5 minutes, and you do have a couple more questions.
Jump in.
I'm going to share this one from Maddie Friedman.
Yep. Yeah, we've actually seen fraudsters complete payment events. Like that real $1 transactions would clear and would actually clear through a bank. And so that gets pretty sophisticated. What I would say in terms of the sophistication of scripting post-install events, there's typically a cliff fall off, meaning if you take all of the funnel events for, let's say, a QSR app, you get an install, you get an open, there's a registration, there might be a loyalty sign up, there might be a deal taken, there might be an order placed. Typically, when the post-install events are scripted, it will get through a path, and then there will be a huge universe where it just falls off a cliff that don't make it to that next step when you compare it to quote unquote random. Capturing random can also be a bit of a challenge, right? Your unattributed universe is not necessarily random. That's just all your conversions that you didn't attribute to media. So understanding the differences relative to organic is typically where we like to start on that. What other questions we got?
Yeah, how about one more, Grant? I've got one that came in with
Please.
registration.
Great.
This one's kind of looking for what's the quick fix?
Yeah. Yeah, what I like is standing up verification rules and then just on an ongoing basis reporting out the violations to the verification you've set up. And ultimately what you get is every single row that outputs on that report, can you justify it to your own satisfaction? Because it's going to output all of the violations that we see. And if for nothing else, it creates a very, very good conversation piece with the network, which, by the way, we love to have with you. Always pull us in with the network. We love to have those conversations.
Let's see, we've got a couple more coming in here. Now the questions are rolling in.
Yeah.
I'm going to share this one from Ashley. See if you have an answer on that one.
Yeah, there's a lot going on with this question. With the PMAX, it's a network grading their own homework. I don't feel great about it, if I'm being honest. Pay-per-click, I'd also argue, can get you in a lot of trouble. Meaning, unless you're very closely watching the converted universe to that pay-per-click, there's lots of opportunities to create zombie conversions that make it look like your pay-per-click campaigns are converting like mad. And so it's one of the reasons why I always go to post-install events and quality views on this stuff. Not to say pay-per-click's a bad deal. There's great value to be had with it, but from our experience, recommend watching it closely. But the same goes for CPM, the same goes for CPI, same goes for CPA. There's ways to trick all of it.
Great. And let's see, I've got a couple more here.
I love it. I haven't seen any of these questions, so I like getting just absolutely in the blind. Let's do it.
And this is probably the last one because we're just down to the wire here.
Targeting's sort of its own weird beast, and we got to break this into like an iOS universe of tactics versus an Android universe of tactics. But some things to look at are, if retargeting is being done at the device level, it will typically manifest with lots and lots of ad signal across very few devices. And so that's usually how that manifests. Now, where that gets tripped up is you're not necessarily expecting an install event on a retargeting campaign because they installed already. So a lot of the ratios like click flooding sort of go out the window. But the things that do remain are the referral strings, the OS types, all of the sort of cohorting by device type. That's how we've historically caught some nefarious stuff going on in retargeting. Anything else on that one, Tyler? You've been close to some of those.
I mean, probably click flooding is the most common for this type of thing, right? Just serving ads to absolutely just covering everyone who's already installed, hoping that they'll do something again.
Yeah, and across certain retargeting partners, we'll see cuckoo stuff like 30,000 clicks registered to a single device. And imagine how tired her thumbs are.
Yeah, reporting impressions as clicks tends to be one while trying to jump a level up in the attribution waterfall there. Seeing like more clicks than impressions, a CTR of over 100%. We see that.
Okay, that takes us down to the last 30 seconds. Thank you everyone so much for joining us today. Grant and Tyler, thank you so much for everything that you shared. Remember, over in that Docs tab, you'll find the one sheet that Grant shared and talked about. And then also just the takeaway, if you're a Kochava customer, turn on your traffic verifier and turn on those tools, because they're going to make a big difference. A lot of people don't use them. And you can make a big difference in the signal that you're getting just by using the tools that your MMP provides. You will receive an email with a recording of this webinar in case you want to go back and review anything else. And we look forward to seeing you on the next one. Thanks, everybody.
Thanks, everybody. Appreciate it.